This video covers a tier list. A tier list in the magic that powers MMOs. Density is the problem. The more players you add, the worse this scaling problem exposes itself. If you have 100 players nearby each other and you collect movement at 20 updates a second, that's going to cause 2,000 events a second. We have 100 observers broadcasting between those players. There's 200,000 broadcasts a second. At 250 players, that's 1.25 million. 500? 5 million. This doesn't even count meaningful interactions to the environment and other broadcasts coming from your simulation itself to the players. This is called Fanout. Fanout has several layers. The Fanout to the simulation, the Fanout to the serialization to the actual network layers, and the Fanout to the bandwidth on the network layer. Let's talk about the bandwidth. If you have a payload of 32 bytes for 100 players, then it's only 6.4 megabytes. If you have 500 players at 32 bytes, then it's 160 megabytes. If this payload's any larger, say this just our general traffic average is 256 bytes, we're already having to push over 1 gigabyte a second off this network card. That's saturating an entire 10 gigabit connection. With that, you can see the difference between 100 players and 500 players is a totally different realm. This is why scaling techniques are mandatory for an MMO backend, and this is why we judge them on that. Simply scaling these messages through batching itself can conserve a lot. If you have 100 moving entities at 20 updates a second and you have 100 observers, the 200,000 updates a second becomes 2,000 updates a second. Much more manageable. For projectiles, unlike players, we really just want to transfer the animation knowledge, the speed it's traveling, what animation it is, and then let the client render that and the server simulate that separately. We don't want to broadcast each movement of this projectile. This is the MMO and MMORPG backend tier list scaling criteria. Scaling means density, specifically density of dynamic entities like players, projectiles, NPCs, monsters. We will use a weighted score system, so let's quickly cover that. The primary scoring is for density of players interacting, density of projectiles and other entities that are interacting with those players, including instantiation of new entities, the efficiency of the simulation between these dynamic entities, and maintaining the interest management and subscriptions observers of these events. Use of good patterns like batching, update coalescing, prioritization between the queues, and back pressure handling between those queues in case of burst events. Depending on the overload condition, we could change the tick rate, reprioritize or modify budgets on queues, anything but actually collapsing our simulation. Since horizontal scaling is not actually a compute reduction, this will be penalized if it is a dependency. Horizontal scaling has its place, instance dungeons for example, but if we were using this to achieve scale in players, we're missing the objective. At a weight of 5%, the formula is 6 minus the score for horizontal dependency. From 1 to 5, 5 being the worst, 1 being the best. F for failures in design, so global locks on a database, having the database in your hot loop be blocking, client being authoritative, just trusting the client blindly just to achieve any form of scaling, collapsing immediately at scale, so having no way to fall back on anything, especially in the simulation in other modules. If there's an exception, does that crush the main loop? Does that terminate connection to all clients? These are just some examples of what we should consider naive designs because they don't scale or attempt at scaling. F tier gets a 1 on scaling criteria. D tier. D for don't expect this to work. Still naive, still not applying performance techniques, just general patterns. Instead of broadcasting traffic to everyone, now we might be scanning for nearby players based off coordinates and thresholds between those, but that would be just in time during the broadcast, so there's no area of interest, so there's no actual management of anything. From our queue, there's no prioritization, so we could have unnecessary things, just consuming the whole tick whenever we have something important to process instead, as well, individually processing that, not doing batching, other just general techniques. still crashing or collapsing under load when the simulation just cannot keep up with the producers. Even with non-blocking async, the database just being in the hot path would still be an issue. That refers to on-disk databases and not those that are in memory or other key value stores. An MMO with only these optimizations scores a 1.1. C tier for could work for low to mid density. This would be your private servers and legacy MMOs. This might look like having different zones where we can have players in a set where we can just broadcast or check membership to those players, but still without much regard or prejudice to the actual update or the update type itself. This means if the producers outrun the consumer, then we get a lag, when we could instead drop anything unnecessary and just process combat events or what is critical. A basic chunking system scores you a 2.35. Not too bad, it might be enough as long as you don't shoot yourself in the foot. B tier. B for basically will work. But at what cost? Because it will be costly. Because B tier is horizontal scaling. It's not pretty and it's not fancy, but taking several processes, bolting those together, transferring a player between those processes, even having entirely remote hosts and just migrating the player's connection between one to the other transparently will achieve us scaling horizontally. Once we begin to introduce foreign processes and remote hosts, then we'll be introducing queues between those so we can actually pass messages and have those processed. Still not solving density, but this will work for sharding and instance dungeons. With this said, and the previous things encompassed under this, you will be scoring a 2.65. A tier for actually will work. At this point, we can begin our special partitioning and chunking systems to keep a neighbor set active for players and entities. This is different from zones and sharding because they're not just different broadcast chunks you're entering into. This is actually the spatial awareness between entities themselves from within those shards or chunks, on an appropriate data structure for moving or static entities. Batching would include the batching of the draining of the queues, the batch processing of events on the simulation, and the batch broadcast on the async network layers. Combine all this with some good overflow controls, and you'll score yourself a 3.95. S tier. S is actually for standard, and you should settle for nothing less for your MMO backend. In all seriousness, this just means we've taken our due diligence to reduce the actual computations done. It's not that our computer cores are running faster, or we've scaled with more machines. It's that we simply have less work to be done. And when we do have an event to be broadcast, we have a very cheap way to know where it needs to go. Basically, we need to use the hyper-efficient data structures, so we need to use chunked, pre-computed aura trees. If our whole map is beatable, then just a normal aura tree. If we have dynamic moving entities, we need our spatial hash or a quad tree, depending on density. Any updates would be coalesced. If you have any horde systems, then you need to use a flow field. That means for pathfinding, instead of each entity doing the pathfinding, you perform those as a group and share the information. Tick budgets and tick time slicers. Things are batched. We handle any overloads gracefully by upgrading anything from a normal queue to a priority queue, with prejudice to the type. Horizontal scaling for dungeons is always welcomed, but we should go ahead and pre-fork those workers. Again, capturing all the low-hanging fruit. We're caching things, pre-computing things as necessary, including network payloads in the hot path. We can pre-encode those, have those serialized and ready to go. With a strong execution model, making use of threads and multiprocesses appropriately, including a heap of memory with one writer and many readers. You might start packing your own bytes over JSON. You might do your own protocol and avoid the encapsulation of TCP/IP. Once we get this all settled, with all things included previously, we start entering the S tier territory. A setup like this will score you a 4.9. Before you go, I was talking to our magic science team. You might want to hear this. This is a table on spatial data structures. We covered this in So You Want to Build an MMO Part 2 if you'd like to check that out. I'm going to go ahead and give you a good look at this now. before we end, let me show you some clips from Ig Engine. You can join us on the public servers, or you can host your own realm. We have cloud hosting options. You'll have a persistent profile per realm, and also a global persistent profile that is your Ig persona on igengine.com. If you want to host your own server, create your own story, we have editors for dialogue, NPCs, items, you name it. There's a whole lot more, but we can't cover that here. Thanks for watching.